Hello everyone, myself Professor Amol Mishra of Department of Electrical Engineering of SND College of Engineering and Research Center, Yeola. Today we are going to discuss on the topic the registers of 8051 microcontroller. The register set of 8051 microcontroller. The, uh, the register set of 8051 microcontroller consists of accumulator, B register, program counter, data pointer, stack pointer, flag registers. We will study these registers in the following subsections. The accumulator and the B register. Accumulator register. The A register is an accumulator register. It is a 8-bit register and it is used for many operations including addition, integer multiplication and division and Boolean bit manipulations. Its function is it is most versatile and holds source operand and receives the result of arithmetic operation including addition, subtraction, integer multiplication, division, and Boolean bit manipulation. Its uses are it is also used for data transfer between 8051 and any external memory. Several functions like rotate, swap, etc. apply specifically on the accumulator. The B register, the B register is used with A register for multiplication and division operations. For further instruction, it is treated as a scratchpad register. That is, it has no other function other than a location where data can be stored. The data pointer. The data pointer, or it is in short term, it is called as DPTR. A data pointer is a 16-bit register. It is made up of two 8-bit registers, that is DPH and DPL. The DPTR holds the address of data in memory. It can be used as a 16-bit data bit register or two independent 8-bit registers, that is DPH and DPL. The DPTR holds the memory addresses for internal and external code accesses and external data access. Some examples of the data pointer register are move C A, comma @A plus DPTR. And second one example, move X accumulator, comma @DPTR. Third one example, move X @DPTR, comma A. The DPTR is under the control of program instruction and can be specified by its 16-bit name or by each individual bit name, DPH and DPL. DPTR does not have any single address. DPH and DPL are each assigned an address 83H and 82H. The DPTR register can be accessed separately as lower 8 bits DPL and higher 8 bits DPL. The DPTR does not have a single internal address. Instead of DPL and DPH are each assigned a separate address. A program counter. Program counter is a 16-bit register and it is also called as in short term PC. PC is the only register that does not have an internal address. It holds the memory address of next executable instruction. The program ROM or read-only memory may be on the chip at addresses 000H to 0FFH, that is 4 kilobytes, external to the chip for addresses that exceed 0FFH. Program counter is automatically incremented, that is +1 after every instruction byte is fetched. The stack pointer. The stack pointer is an 8-bit register used to hold an internal RAM address that is called the bottom of the stack. The stack pointer holds the internal RAM address where the last byte of data was stored by a stack operation. When data is to be placed on the stack pointer increments before storing data on the stack so that the stack grows up as data is stored, that is push. As data is retrieved from the stack, the byte is read from the stack and then the stack pointer decrements to point to the next available byte of stored data. It's called as pop. After reset, the default value of stack pointer is 07H. The microcontroller stores the information or data like stacking plates, shows stack plate. If we want to remove the first stack plate, then we have to remove all the plates above the first. That is, we have to remove the fourth plate, third plate, second plate, and then finally the first plate. This indicates that the first plate pushed onto the stack is the last one to be popped from the stack. This operation is called as first in, last out. The program status word or PSW or flag register. Deny instruction affect the status flag. In order to address these flags conveniently, they are grouped to form the program status words. Flags are 1-bit registers provided to store the status of the result of some instruction. So, and then we are seeing what is flag. A flag is a flip-flop that indicates some condition produced by the execution of an instruction. Example, the carry flag will be set if there is a carry or borrow out of the MSB of the result. It contains math flags user, program flag F0, register select bits that identify the register bank that is currently in use. The 8051 has 4 math flags that include carry flag, auxiliary carry flag, overflow flag, and parity flag. The carry flag will be set when there will be a carry or borrow out of the MSB, that is D7 bit of result. The auxiliary carry flag. The auxiliary carry flag is set whenever there is a carry out of the lower nibble into the higher nibble, or whenever there is a borrow from higher nibble into the lower nibble. The overflow flag. The overflow flag will be set if an arithmetic overflow has occurred, that is, a significant bit has been lost because the size of result exceeded the capacity of its destination location. The parity flag. The parity flag is set when the result has even parity, that is, even number of ones. The bits RS0 and RS1 are used to change the bank registers. The symbol of CY. In this chart, we have studied the symbol and its function. In bit number 7, the symbol is CY, that is, its full form is carry flag, and it is used in arithmetic, jump, rotate, and boolean instruction. 6. In bit number 6, the auxiliary carry flag, it is used for BCD arithmetic. In bit number bit F0, user flag 0 is used. RS1 is a register bank select with 1. RS0 is equal to register bank select with 0. OV means overflow flag used in arithmetic instruction. And the bit 1 is reserved for future use. And 0 means P or parity flag shows the parity of register A. 1 is equal to odd parity. The special function register, data register, and control registers. The control registers are timer, serial ports, interrupt system, analog to digital converter, digital to analog control converter, etc.